Easily we can determine the acidic character of carboxylic acid. So now the main heading is start. This is called acidic character of carboxylic acid. Okay. So the next topic we have, that is called acidic character of carboxylic acid. It is very simple to understand. Based on class 10th, if we have given any acid, so we used to react with metal. If the hydrogen gas was liberated there, so it means the given unknown chemical is your acid. Okay. We are not concerning here, or we are not worried about the strength of acid. To find out the strength, we will be following the method pKa value that I told you. If the value of pKa is high, so it means the acidic character will be low. Clear? So there are different methods. First method I told you, which is the value of pKa. Second value, that is a relation between electron releasing group and electron withdrawing group. Third, we will be having a completely series based on the comparison. Means there are so many other groups, like fluorine is there, if chlorine is there, if fluorine and chlorine is there. Or basic example, if I ask you, let us take that example. If I am having HCOOH and on the other hand I am having CH3 single bond C double bond O and OH, which is more acidic. How will I find out the acidic character, or which one is more acidic? There are two groups. First is H, second is CH3. So CH3 is having more electron releasing density. So it means the flow of electron from the CH3 part will be toward carbon. On the other hand, here it is also having the flow, but since the electron density is very low, so flow of electron will become very easy. Okay. Here it is having more electrons, so it will be taking too much time. On the other hand, it will be having only one electron, so it will take very few seconds or milliseconds. That is why the acidic character of the methanoic acid will be high than the ethanoic acid. Simple. These type of explanation I am giving to you, these explanations comes normally in the CBSE exams. But in competitive, they will be either asking which one is the acidic character. Simple. So directly I can say, if I increase the carbon number, for example, if I had used CH3 twice, okay, and then CH2 here and then COOH here like this, so the acidic character of this one will be again released, or sorry, decreased. Means more the electron releasing group you attach, more the acidic character will start reducing. Clear? Okay. So electron releasing group decrease the acidic character. Means here I am writing in this pattern, simple for the understanding. So electron releasing group, if the number of electron releasing group had increased, so the acidic character of the carboxylic acid will be decreased. Is this clear? Fine. So now based on this one, on the other hand, we can also write down, sir, if the electron withdrawing group number had increased, so the acidic character will be increased. So the acidic character will be directly proportional to the electron withdrawing group part. Is this clear? Okay. On the other hand, stop writing, first understand, this is important. So here, let me take an example. If I am having simple carboxylic acid CH3 single bond COOH, if we react with sodium, so directly we had seen a reaction that it will be representing in this pattern like this, with releasing of H plus, or you can say the hydrogen gas also. Clear? Okay. Carboxylic acids are highly reactive acids in comparison to the alcohols. But why it is there? If I am having alcohols, let us take CH3, CH2OH, and if I react with the sodium, so the answer will be almost in the same behavior. That is our CH3, CH2 and ONA and plus H plus. But Why carboxylic are highly reactive here? How do we identify this? So it can be identified simply that if the carboxylic acids are reacted with strong base also, let's take NaOH or KOH. So carboxylic acid do the reaction with strong base, but alcohols are not that much acidic in character so that they could react with strong base. Means they are good acid, but they are not having the intensity of acidic nature very high in comparison to the carboxylic acid. So the potential of the alcohols are very low in comparison to the carboxylic acidic nature or carboxylic acidic potential. So that's why if I take the alcohol again and if I do the reaction with NaOH here, so the reaction will not take place with alcohol. Why? So the reason we will be writing, because they have acidic nature, but the value of acidic nature is not that much enough to react with NaOH. They do not have that much value. Is it clear? On the other hand, if I take the carboxylic acid, so CH3 C double bond O single bond OH plus NaOH, so directly they will do the same behavior, that is CH3 C double bond O and ONA and plus H2O. So it represent number first difference, which represent the carboxylic acids are highly reactive than your alcohols, because directly you can take the Na or NaOH. If you take for example dilute NaOH here, dilute NaOH, first you are taking with the alcohols, so alcohols are not doing the reactions. On the other hand, carboxylic acids are showing very fast reactions. Means although the reaction will not be that much faster, okay, in comparison to the inorganic acids, but this will be faster in comparison to the alcohols. Means alcohols are not reacting and they are reacting, so it means it is a difference there. First point is clear. Second, let's take few more examples based on the electron releasing group. Okay, so question number first is there. I am having, first let's take CH3COH, second I am having CF3COH, third I am having CCl3COOH. Okay, one more I am taking, let's take CH2 single bond NO2 single bond COOH. Okay, one more we can take here, let's take, okay, here I will write down. So that is our CH3 single bond CH2 single bond COOH. So question is, we have to predict which one is more acidic in character. Okay, again our focus would be first on electron releasing part, second on your electron withdrawing part. If you do not have any options apart from these two, so we will follow the pK value pattern. Since the pK value is not given, so we will follow only the first pattern. This point is clear? Okay. First we will compare these two. Yes, which one is more acidic, here and here. So here in the first one, carbon is directly connected with 3 hydrogens and it is directly connected with COH here. Here, second CF3 part, CF3's carbon is connected with 3 fluorines here, and then this carbon is also connected with COH. So if you look properly here, hydrogen is actually having a nature to give electron to the carbon. So here also and carbon will be giving, means the flow of ultimately electron will be toward COH. If the flow is toward COH, so instead of releasing H positive easier, OH will be released easier. Here fluorine is electron withdrawing group or more electronegative than carbon also, so the flow of electron will be toward ultimately fluorine. If the fluorine will be taking the electron direction, so it is away from carboxylic acid. If it is away from carboxylic acid, so carboxylic acid will have to release H plus to be stabilized. Means this functional group or this group for fluorine is making carboxylic acid to release H plus. Is this clear? So in these two compounds, so our winner will be this one, means this is more acidic than this one. Am I clear? Sir, this is more electron withdrawing group nature or electron withdrawing nature. Here the nature of this group is electron releasing. Any doubt? Huh? Clear? Okay. Now come back here. If I compare now these two, which is a little bit typical, but not that much typical. Here carbon is connected with fluorine, this fluorine and directly connected with C double bond O and OH, and second I am having carbon which is connected with chlorine and again it is connected with COH. Point is both are electronegative, so both will be having electronegative nature. If both are having electronegative nature, so both will be showing that is flow of electron toward themselves. Chlorine